sequence out here is being defined as being symmetric about the mean. What exactly does this tell us? It tells us that if you have a reference point for that sequence, then in order for something to become symmetrical, symmetrical means equally distributed on either side. So if you have terms on this side, which is, let's say, this much distance away, you will need its partner on the other side to form the symmetrical pattern. If I have another term here, I'll have to have yet another term here. If I put one more term here, I will need to put one more term here. As you can see that on the number line, we are looking at symmetrical behavior or symmetrical distribution. The question tells us that the values are symmetric about the mean, which means that the mean or the average of this entire sequence is this reference point. Which means in this case, the mean automatically becomes the median. In fact, that's true for any symmetric sequence. Now, in percentage terms, if you look at the coverage, the position where the mean comes has to therefore be at the 50% mark because it is right in the middle of the sequence. And how do we know that? Because we have been told in the question that the distribution is symmetric about the mean. So the mean is coming right at the 50% mark. This is one of the important inferences you'll have to draw on this question, because ultimately we are dealing with the percentage of values covered, not the actual values. The next crucial piece of information to factor in is standard deviation. Now, fortunately, this question does not require any deep understanding of the word standard deviation. When you are told it's one standard deviation away, you can even, for all practical purposes, consider one standard deviation as one step or one leap. So here we are told that 68% of the values are within one standard deviation of the mean. So the mean is out here, and within one standard deviation of the mean could be this side and also this side. And this total coverage is given to us on the question as 68%. 68% of the values are within one standard deviation of the mean, which means on either side. Now clearly one deviation is this much to the right, and similarly there's one deviation to the left, which tells us that each deviation D in fact covers just half of 68, which is 34. That's how you get total 68 combined, because we have 34 on either side. So this portion is covering 34% of the values, and till the value M, which is the mean, we are covering 50% of the values. Once you figure this out, it's very easy to now answer the question that is being asked. The question that is being asked is what percentage of values are less than M plus D. So less than M plus D, M is still here. If we go further ahead by D, we are going to come somewhere here. This is at the 50% mark. This is another 34% out here. This entire thing was already 50%. So the total that we are covering, which is less than M plus D, which is this point, is 50 plus 34, which is 84%. That is the answer to the question. Symmetric sequence is one of the 6 sequence types that you get on GMAT. I have covered all 6 of these in another video. The link to that is given in the description below. And also links to videos where I have solved one example of each of these types.